Good afternoon. Once again, this is Professor Parker, and welcome to All This Math. If you have not already subscribed to the All This Math YouTube channel, please go ahead and subscribe. Hit the subscribe button. Also, turn on notifications. Hit that notification button so when I put out new content like this, you will be notified of it. All right. Also, I do want to say that the late Fannie Lou Hamer recently had a birthday, so that's why I have her t-shirt on right now. So I want to wish a happy belated birthday to Fannie Lou Hamer. If you are watching this video and you are not familiar with Fannie Lou Hamer, who she was, her legacy, and the work that she did for people of African descent, please get familiar as soon as possible. Please get familiar with Fannie Lou Hamer, who she was and what she represents to our people. All right, now, today, in this video, we're going to get into some geometry. All right, we're going to get into some geometry. I have a figure drawn back here. Now, as you probably see the reflection of the ring light right around here somewhere. I'm trying to get the hang of this lighting thing, so please bear with me. I'm gonna figure that out. But this is an 83-degree angle. I'm gonna make sure that when it comes to the part of the video where we're talking about information that deals with where that ring light is real extra bright right there, I'm gonna let you know what information is right here. This is angle D, and it has a measure of 83 degrees. But at any rate, we have this diagram right here. We basically have two triangles that are adjacent to each other that share a common leg, right? One triangle and another triangle, right? And what we're gonna figure out is the measures of some angles, all right? So we're gonna figure out the measures of some angles, okay? Now, we got four angles we gotta figure out. Angle 1, angle 2, angle 3, and angle 4. Angle 1, angle 2, angle 3, and angle 4. And before we even get into that, when you approach geometry problems, you should always read the given information. So here we have given information up here in black. It says that segment BC, or leg BC, which is from point B to point C, point B to point C, that's what that means. And that little horizontal bar over the top that looks like the repeating sign, when you have a repeating decimal, that's a symbol for a segment, meaning it starts at a point and ends at another point. It's not a line, because lines go on forever. Lines never stop. They go on forever in opposite directions. If it was a line, it would have two arrowheads at the ends, but it doesn't. That's a segment. Point B is right here. Point C is right here. This BC represents everything between point B and point C. All right. So we know that it bisects angle. That's the angle symbol, ACD. Now we need to understand what ACD is and where it is. We need to understand that. The middle letter, when you're describing an angle, if you're describing an angle using three letters, in this case we are, angle ACD, the middle letter is the vertex of that angle. So if you need to, pause the video, rewind that, write that down, put that in your notes. You need to know that. The middle letter is the vertex of the angle. Now, what's a vertex? A vertex is where the two rays or the two line segments that form the angle, where they come together and where they meet. So like, if this is one ray, this is another ray, boom, where they meet, when my hands came together, that's the vertex. So find point A, it's right there. Find point C, it's right there. Find point D, that's right there. I already told you the middle letter is the vertex. Point C is the vertex. So this angle is formed between AC and CD. So when AC and CD join together, when they come together, when they unify, they form angle ACD. So this is the angle right here. Now this angle actually is made up of two separate angles put together. This one and this one added together. All right. Now go back to the information. It says segment BC bisects angle ACD. That's the angle symbol. This little symbol right here. Bisects angle ACD. Now bisect basically means to cut something in half into two equal parts. It's like if you're making a sandwich, you cut it in half, you make sure the left side is equal to the right side. Usually that's what people do. You might be different, but usually you cut two pieces of a sandwich and each half of the sandwich is just that. It's a half, right? The two halves added together total into one. So that means that this line segment cuts this angle in half. Now, in case you don't know, this little box symbol right here, this indicates that this angle or angle ACD is 90 degrees. It's 90 degrees. That's what that means. That means it's 90 degrees or it's a right angle. So that's important to know because I just told you what the definition of bisect is. Bisect means to cut in half. So if I got an angle that's 90 degrees big and I cut it in half, All you got to do is ask yourself, well, okay, what's half of 90? Half of 90 is 45. 90 divided by 2 is 45. So what that means is this. That means that this angle is half and this angle is the other half, because this line segment bisects or cuts this 90-degree angle in half. So that means this is 90. I'm sorry, I'm tripping. No, this is 45. Angle 2. See these numbers right here? These numbers are not angle measurements. These numbers are just like names. Like we all have names. This angle has a name. We call it angle 2. This angle has a name. We call it angle 1. This angle has a name. We call it angle 3. This angle has a name. We call it angle 4. So angle 2 is going to be 45 degrees. And angle 3 is going to be 45 degrees. Now, again, how do I know that? In geometry, you can't just pull stuff out the air. We got to have rules, use theories, use postulates to justify any conclusion that we arrive at, right? Now, what we just used was the definition of an angle bisector. The definition of an angle bisector. Because the definition of an angle bisector is it's a segment or a line or a ray that cuts an angle in half. So if I already know that this angle was 90 and you cut 90 in half, you get 45 and 45, because 45 plus 45 is 90, 2 equal pieces. All right. So I know angle 2 is 45. So I'm going to go over here. I'm going to write my answer for angle 2. Angle 2 is 45 degrees. Angle 3 is 45 degrees. Now I'm left with angle 1 and angle 4. I got to figure them out. Now, there's a different rule that we're going to use in order to figure out what the measure of angle 1 is and what the measure of angle 4 is. Before we get into that, I want you to think about something. We need to talk about the definition of a triangle. Part of the definition of a triangle is that a triangle has 3 angles. As in tri, it's got 3 sides and 3 angles. The prefix tri means 3. All 3 angles in any triangle, and this is something you need to memorize, all 3 angles in any triangle will always add up to 180. It will always add up to 180. If they don't add up to 180, then it ain't a triangle. It's that simple. If it's more than 180 or less than 180, it ain't a triangle. All 3 angles must add up to 180. So in order for this to be a triangle, all 3 of these angles must add up to 180. So this angle right here, which we don't know the measurement of yet, this angle right here, which we do know, is 50 degrees. And this angle right here, which we just figured out was 45 degrees, they must add up to 180. So the way I try to break this down is a lot of times people are uncomfortable with geometry and uncomfortable with what they consider to be higher level math. I try to make it real practical for you. So I want you to think about it like this. Let's say that you needed to get $180 to purchase something, to pay a bill, to invest in something, or you need to save $180 towards something, you're trying to build community or something. You're trying to pool resources. You're a part of a susu or something, whatever it is, right? You need $180. Let's say you already had $50 and you know that somebody's about to give you $45 tomorrow. The question is, how much more money do you still need to get to the 180 that you need? You got 50 already, and you about to get 45. That's guaranteed. You trust that. So what I would do is I would add the 50 that I already have, plus the 45 I plan on getting. That added together is going to be 95. 50 plus 45 is going to be 95, right? 50 plus 45 equals 95. Now, but altogether I need 180. So now the question is, well, how much more do I need? If I need to know how much more, I'm looking for the difference between 180 and this 95. So that's going to look like this. 180 minus 95. And 180 minus 95 is 85 degrees. Or in that case, in the case of my practical example, it was $85. But we apply the same mathematics to the geometry. Except in geometry, we're talking about degrees. So that means angle 1 is 85 degrees. That's what that means. 85 degrees. So angle 1 is 85 degrees. Now, what we just used is called the Triangle Sum Theorem. The Triangle Sum Theorem. And it's called the Triangle Sum Theorem because what it indicates is that all 3 angles of any triangle must add up or have a sum of 180. And with that information, if you know that, from there you can deduce what the measure of a missing angle needs to be, which we just did. We just used the triangle sum theorem right here. Now we go over here to angle 1, and I say, okay, 85 degrees. Now I got one angle left. One angle left. All right? I'm trying to find this right here, this angle 4. Now, in this triangle, I know that I have angle 3, which was 45 degrees, because we talked about that earlier. And I know this is 83 degrees. Now, like I mentioned earlier, you might not be able to see this that clearly because of the ring light reflection, but this is 83 degrees. 83 degrees. All right, work with me. This is 83 degrees. Write that down on your paper. Hopefully you're taking notes. All right, 83 degrees. Now, again, this is a triangle. It's got 1, 2, 3 sides. It's got 3 angles. All 3 angles, due to the triangle sum theorem that we trust and we believe in, all 3 angles must add up to 180. So if that's the case, then that means that angle 3, angle 4, plus the 83 must add up to 180. So again, we're trying to get $180. We already got $83, and we also already got $45. We put the 83 with the 45, do a little bit of math. 83 plus 45. Hopefully you can do this mentally. You know, I know a lot of people try to grab their calculator in certain situations when they probably really shouldn't need their calculator. Really, because what you do is you could just add the 10s, 80 and 40, just like when you count money, right? You got 80 and 40, that's 120. Then you got 3 plus 5, that's 8. So that's 128. That's 128 degrees right here. These 2 angles make up 128 degrees. All 3 angles put together got to add up to 180. So So the question is, how many more degrees do I need to complete this triangle? That will be the measure of angle 4. So how much more? And think about this too. This is also a lesson in mathematics language and word problems. How do we approach word problems, right? How much more, when we use that phrase and that terminology, we're talking about subtraction. When you're trying to find how much more do I need? How much more do I need to get to this amount? So that's an indicator of subtraction. So we're going to do 180 because that's the total amount. And then we're going to subtract this 128. Now 180 minus 128, again, do some mental math. This is how I would do it myself personally. It's a lot of ways to do the mental math with this. But the way I would do it is, I would round the 128 up to 130. So that way both of my numbers end in 0. 180 ends in 0 and 130 ends in 0. Round the 128 up to 130. Do 180 minus 130. That's 50. If that seems too complex, then just think of it if it was 18 minus 13. Drop the zeros off for a minute. 18 minus 13 is 5. 180 minus 130 is 50, right? Because all we're doing is expanding it by 10, by a factor of 10, right? 180 minus 130 is 50. Now, I rounded this up from 128 to 130. So that means I took away 2 that should have been, it's like 2 less than what it should have been. So 180 minus 130 is 50, but I got to add those 2 degrees back in. So that's going to be 52 degrees. And that's the measure of angle 4. 52 degrees. There you go. And now if we wanted to check our work, what we would do is just go into each individual triangle, add up all 3 angles and make sure that they add up to 180. Now we know that they do because of the fact that we used the triangle sum theorem already anyway. You know what I'm saying? So again, just to recap, we now know what the term bisect means. We know what an angle bisector is. We know the symbol for a segment, the symbol for an angle. We know how to name an angle. Remember, the middle letter is your vertex. The vertex is the part where the 2 rays or segments come together and where they unify, right? This is about unity. You know what I'm saying? Right? So also we know how to use the triangle sum theorem. The triangle sum theorem. Geometry just has a whole lot of theories and postulates and laws and corollaries and, and whatnot. But as you use them over and over again, they become very easy to remember. And then you start to just, utilize them without even thinking about it. And at that point, that's the point you want to get to with math, because that's when your mathematical muscle memory is kicked in. When you just start using theories, when you just start looking on the paper or looking on the board, you see a problem. You're like, okay, I automatically just recognize how these angles are related to each other, or how these shapes are related to each other, or how these lines or line segments are related to each other. So, but yeah, this is something, I wanted to get into. I wanted to talk about the triangle sum theorem and also show you how to work out problems involving the triangle sum theorem. So once again, I'm going to say this. If you have not subscribed to the channel, please subscribe to the channel, turn on the notifications, and share this video with somebody. Because Because if you need it, if you benefited from it, somebody else will probably benefit from it. So, you know, share the wealth. And as always, as I always say, do remember that there's all this math all around you. Peace.